Hello, everyone. I'm Anshu Agarwal, CEO and co founder of Nimbella, a serverless cloud provider. Today, I'm going to talk about what is stateful serverless and what is needed for a widespread adoption of serverless in the enterprise. First, let's go over the evolution of cloud computing. Throughout this evolution process, we have had multiple forms and abstraction levels. The data center, whether it's on premise or it's provided by a vendor as a service, was the first step to the cloud as we know today. It abstracted the physical hosting environment and we started scaling those environments with hardware units. I personally started my career in cloud computing in the CDN industry, and I believe CDNs were really the first cloud service. When we were doing that, we actually installed rack servers all over the world in various data centers. As virtualization evolved, we started hosting virtual machines on the cloud environments. We abstracted the hardware and used the operating system as the unit of scale. Soon after that, we built hosting environments in the cloud and abstracted the operating system. Our new scaling unit was the application, but this was not the end of the journey, as now we've moved to functions or serverless architecture. All of these cloud models leave us with different responsibilities. Having the data center on premise means that we have full responsibility over everything that is going on there. When moving to the cloud, each step in the evolution leaves us with fewer and fewer responsibilities, and greater a level of abstraction comes with greater level of automation. Now we are going to double click on what these phases of evolution actually did. So this particular chart shows that more and more of the cloud platform stack is becoming the responsibility of the cloud vendor. So the darker blue actually represents the work that the cloud vendor has taken upon them, and the lighter blue is what is a user or a developer's responsibility. The value for companies is that they can offload a lot of the responsibility to the provider now. For FaaS, which is also interchangeably used as serverless, the cloud vendor manages the applications and users focus on data and functions and features. Serverless architecture actually came after SaaS, but it is shown before SaaS in this chart because in the case of SaaS, users don't control anything about the application or its infrastructure. FaaS, as I mentioned, FaaS and serverless are used interchangeably, but serverless is bigger than FaaS because serverless definition includes building complete applications and it's evolving, and applications are not just functions. Serverless architecture allows to build pieces of code that do something useful and at the same time run quickly without consuming large amounts of server resources. So, but why is this important? I mean, what is this so good about serverless computing? The things that are really fantastic about serverless computing is the benefit is provides the organization, the developer, and the DevOps team. So fundamentally, FaaS is about running backend code without managing your own server systems or server applications, since there are no servers to run. So huge time savings from DevOps perspective. The next biggest benefit is auto scaling. There is complete horizontal scaling, which is automatic, elastic, and it's managed by the platform or the FaaS vendor. It is true pay as you go service. You never ever pay for idle capacity. So if you are successful as a company, you pay, and if the business is not doing well, or if you don't have enough traffic or consumption of the resources, you don't pay. So it's true pay as you go. The last one, which is actually the most important aspect of serverless computing, is that deployment is very different from traditional systems. You upload the code to the FaaS provider, and it does everything else. All of this results into faster development and deployment, leading to faster time to market, which is what every company is looking for. So we discussed what's the evolution of cloud computing. We also talked about what is serverless and the benefits of serverless. Now let's get on the same page of what a stateful application is. A stateful application is one that saves data about each session and uses that data the next time a request is made. Whereas a stateless application does not save any data generated from one session to another session. I want to touch upon this particular paper that Berkeley Eakes Department published in 2019. But before I do that, there was a paper published in 2009 by the same department, and it was about Berkeley's view of cloud computing and how it will accelerate. So this was written 10 years later as a logical successor, and they talked about how serverless computing will grow to dominate the future of cloud computing because they predict the issues that they have raised are very solvable. Um, let's now talk about the issues because they're very, very germane to our discussion of statefulness. The first issue they raised is that there is no storage for fine-grained operations. The applications that are built on serverless infrastructure require storage services with transparent provisioning, the storage equivalent of compute autoscaling. So what we need is ephemeral and durable serverless storage and not just serverless compute. The second issue that was raised is the lack of fine-grained coordination mechanism. To expand support to stateful applications, serverless frameworks need to provide a way for tasks to coordinate. For instance, if task A uses task B's output, there must be a way for A to know when that input is available, even if A and B are residing on different nodes. So what we need from the serverless infrastructure is the serverless ideal of block storage, which is there when you need it, and it is transparently provisioned for your cloud functions. The third issue that was raised is the poor performance for standard communication patterns. In serverless computing, the application doesn't control the location of the cloud functions. This can result into O of n or O of n square, depending on the use case. And since n is very large in the case of functions than in the case of VMs, this becomes a problem at scale. So what we really need is locality management, and I will talk about it in much greater detail later in the presentation. So hold on to that. The last issue that was raised and it is very commonly known in the serverless community as the cold start latency. The delays could be because of the time it takes to start a cloud function or the time it takes to initialize the environment of the function that is loading various libraries needed, or it could be application specific initialization in user code. Depending on the application, the last two could be way more significant and lead to completely unpredictable performance. So what we need is multiple ways to reduce this by either pre-warmed containers or sharing the models between functions. And there are ways to reduce that. So while after this paper was written the same year, Dr. Tim Wagner, who is the creator of AWS Lambda, also presented in a conference, and you'd be able to relate to it very well after going through the issues that Berkeley paper raised. That we need low latency storage, function to function networking, serverless data flow graphs, real time scheduler, which to do interesting things which are not stateless. We could do, if we did that, then applications such as big data, analytics, MLAI, or video transcoding, all of these applications are possible. And it opens up the world of serverless computing to a wider range of applications, such as shopping carts. We talked about machine learning models, recommendations, anomaly detection, and a whole suite of new applications that can be created from shared collaborative workspaces or workflow orchestration. The possibilities are endless. All right. So we talked a lot about the issues and we touched upon what is needed for the enterprise. But now we are going to talk about what is really needed for making the serverless suited for the enterprise. Okay. We're going to double click on some of the things that we did not cover completely, but we are going to touch upon some other things that are needed for this to be successful. So we talked about state, and now we're going to talk about, what kind of support is needed for stateful applications. We'll also touch upon issues like developer experience because that is needed for successful development environment for the developers, and also the portability that is needed when you are at scale. So applications aren't just functions, and interesting applications have state, and there's many forms of state. If you're building an API, it has a front end component and a web component. You need storage. But the kinds of storage you need are different. So if it's an application that has a front end UI, you upload those assets to an object store. That's one form of storage. If you are handling session state or transient data streaming properties, you might use a key value store. If you're handling files and your applications need to process images or PDFs, you need a file system. And then there's databases, and there could be many different forms of databases. So you need a declarative approach to these so they are available to a developer when they need it. They should scale in a serverless manner, so a developer's responsibility does not include management of those resources or backing up those resources, and it should also provide the built-in performance and cost optimization. But what is the real big deal about it? Why can't we use the individually managed storage services that are offered by the cloud vendors? The reason is that it doesn't work, as it was pointed out in the Berkeley paper also. In serverless and in containers as a service, you don't have locality. You don't know where your functions are running. You don't know where your containers are running. But you need access to data. And so if you can co-locate compute and data close together, you have sub-millisecond latency. You can take advantage of system level caching to help reduce your costs. And that translates into a better application performance also. And there's a lot of value in doing that. There are fundamental technologies that are sort of primitives that a platform has to provide. And then there are capabilities that you can do it at the user level. You can't optimize your cache, your compute, because cloud providers do not provide you access for doing that. These are things that the underlying platform has to do automatically. And if I get back to what a serverless promise was, it's about freeing the developer from having to think about various things. If you want a concept of a key value store, you should just be able to use it, not think about where it's provisioned, and how it's backed up. It is to provide this programming model backed by underlying cloud technology that allows us to broaden the set of capabilities that not only functions can do, but serverless programming in general allows you to do. So if you look at it from a responsibility standpoint, logic remains the responsibility of the developer, where it should be. Read and write state is completely managed by the system. So it becomes very simple for a developer to actually get the application done. Serverless makes it very simple to develop cloud native apps, but there's a whole lot of developer tooling that is needed to make the serverless experience richer, something that developer is already used to in the serverful world. In addition, it needs to be easy for them to take their local development to cloud. So they are increasingly developing and testing directly in the cloud, and there are no surprises when they move their application from their local machine to the cloud. Also, developers should not need to assemble the tools that they're using for debugging, tracing, monitoring. They should all be integrated. Their experience actually needs to be uniform so to reduce the developer friction and also increase the adoption. And the best way to do that is to integrate with their existing IDEs or complement what they do in their terminal. The last requirement I'm going to talk about is portability. Portability doesn't come into account until you have scale or you need to use some specialized service in another cloud. It is very hard to move from one cloud to another if you are using um, a lot of cloud vendor APIs. You want to code once and be able to run anywhere, so it becomes extremely important to use something that is cloud vendor neutral. Also, you want a developer experience that is uniform across clouds. Another important requirement could be, which is applicable to companies in regulated industry, is running on private cloud. This is a requirement that should be considered while architecting your serverless application. Now I'm going to show you a demo that uses optical character recognition and text-to-speech. This is a serverless application using a React front end and stateful functions on the back end. So if you go to nimbella.com and you see there are stateful serverless applications examples here, we're going to click on optical character recognition. And this application displays a web page where users can select a language. So right here, you can select English, Spanish, Chinese, and then you can drag, and I'm going to pick some files that I already have. You can drag some JPEGs or GIFs into your application. And if the conversion is successful, it will the text will change to green. And as you can see, it's polling how much it's done. So this is 80% done. This is 75% done. So it's actually using the Tesseract OCR engine for conversion from image to text. But what's more important here is how this example makes use of integrated storage services. So the web content that's on the screen is deployed as static assets and served from CDN. That's one form of storage. The second form of storage is the functions that use object store to upload and download the images that were provided by the user. And the third form of storage was the object store abstraction that they are using for sharing the language model between the functions. And the fourth one was the functions recording their progress into a key value store, which we were able to query during until the process was complete. So in addition to this, you can click on any of this and it uses the text to speech and you can.
What is serverless? Like many trends in software, there's no one.
So that's the demo. And now I'm going to walk you through the data flow of this to show how simple it was. So I'm going to go back to my PowerPoint and share that screen. All right. So we covered that. All right. So what's going on here is that when a user uploads the image, a function is created that creates the OCR job, and it posts the details into this key value store. This function returns a URL, signed URL, and the image is stored using that signed URL in this object store. The data flow is optimized by sending the image to the function, and the function fetches the language model, which is shared by any number of functions that are using that language model. The function also updates the job progress. This does require deep platform integration, which is not possible at a user level. So just to give you an example, if one function takes about 2 seconds to load the model, the neural network model, language model, with stateful application, stateful serverless application on Nimbella platform, it actually uses 2 seconds for 1,000 functions or even more, any number of functions. But if there was no stateful built in to the platform, it would be 2 seconds times the number of functions that are being performed. So as you can see, this is it becomes very expensive if you are going to not manage state in the platform. Again, this is how the querying of the job progress was done through the key value store. So if you like this example, there are several examples like that, and the code is all open source, so please do check it out on Nimbella GitHub. And you can also reach us at devrel@nimbella.com or join our Slack community channel. Well, thank you for listening to me, and I'm open to any questions now.